look at our last word problem down below. The picture kind of goes with the words up top. This problem, there's one just like it in my math lab. It tells us that we're using matchsticks and we're making this little design here with these matchsticks. They make these squares. And we want to know how many squares would be in the 10th figure. Well, you could draw it out, but I'm going to tell you it's a whole bunch, so you're probably not going to want to draw it out. So instead, I'm going to find the pattern. So I'm going to count how many squares there are. 1, 2, 3, 4, 5. The first picture has 5 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The second picture has 11 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. The third picture has 17 squares. So it looks like my pattern is I would add 6 every single time. So very similar to this first problem that I did up here where I kept adding 800, I'm just going to keep adding 6. So square 1 had, or first picture, sorry, had 5 squares. Second picture had 11 squares. The third picture had 17 squares. If I keep adding 6, I would get 23 for the fourth. Then, sorry, the 3 didn't come up. 23 for the fourth. Then 29. Add 6 more would be 35. Then 41. Then 47. 53. And the last one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th one would have 59 squares. Now I'm going to use this 6 down below in the next part. It asks for the nth figure. That does not mean 9th or 19th or 90th. It means my answer is going to have a variable in it. It's going to have n in it. So my answer is going to kind of look like an algebraic expression. I'm going to carry this 6 from that I just used, that was my pattern. And I'm going to start with 6n. 6 because that's what I was adding each time. That's what I was increasing by. And n because it said nth figure. Now this isn't my final answer, but it's how I start the problem. What this tells me, if I plugged in 1 into my formula, 6n, the answer should be 6. But if we look back up here, the answer isn't 6, it's 5. So this really needs to be 5. So you get 6 to turn into 5 by subtracting 1. So I get 6n minus 1. Let me show you that again. All right, I'm going to pick another number. Let's say we know the third figure has 17 squares in it because we counted that up there. So if n equals 3, I know I started with 6n, so I'm going to plug that in. That would give me 18, but I know the answer is supposed to be 17 because I can count it right out there. I know the answer is 17. So to get 18 to turn into 17, you subtract 1. So that's why I have the minus 1. I'm just going to erase it here so I can work this last problem a little bit better. C is very similar, but this time it's going to ask for the number of sticks. And I'll just tell you, it's kind of a pain to count the number of sticks. So then this first one, you really don't overcount them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I missed 2 of them up there at the top. There are 16 sticks in this first picture. Let's try for the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. There are 34 sticks in this second one. If you want to do the third one, you can. But we can go ahead and work the problem without that. So it's going to work just like B. If you need to pause it and like rewind and rewatch B, I want you to see if you can figure out how you write that expression. It's going to be something with the n in it again because it's asked for the nth figure of the sticks. So how many sticks there are. All right, if you haven't tried it, really and truly try to set it up. But here we go if we have tried it. 34 minus 16 is 18. So that means we're increasing by 18 each time. So that's going to be 18n. That's like my 6 from this part A and B. I added 6 each time. That's where the 6n came from. To get from 16 to 34, that's 18 more sticks. So it's 18n. If I plug in 1, I get out 18. But it's not supposed to be 18. It's supposed to be 16. So to get 18 to turn into 16, I subtract 2. A lot of these you're going to see do have subtraction. You can make them with addition though. So sometimes you might have to add. So that is a possibility. Like if I plugged in 18 and it needed to be 19, I would have put plus 1. So you might have to add or subtract. It does seem to be more subtracting than adding though.